Hey guys, today's video we're going to be working on this SaintSmart Corception 300. There is another version of this printer made by Creativity, and that model is the ELF. Both of these printers are large format printers, 300 by 300 by 350 build volume. One thing that I found real interesting about this particular one is that it does include linear rails. Another thing that I liked is that it comes with dual lead screws for the bed leveling system and direct drive. Also, that's kind of neat is that it uses some type of a plug system. It's a VGA style plug, which is kind of cool that they would implement something like that. That means you can work on the hot end without having to undo all the cables, which I thought was pretty neat. But the printer never got very good reviews or mixed reviews. Unfortunately, SaintSmart no longer makes their version, the Corception 300. I was fortunate enough to pick this one up as an open box, and they might still have more available. But the Creativity version is available. You can pick that one up. It's about $5.99. And one thing that I always wanted to install on one of my printers has been this BIQU H2 direct extruder by BigTreeTech, and I purchased one of the latest versions here, and we're going to install it on this printer. Guys, if you're new to the channel, please consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments and do my best to respond to you guys as soon as possible. All right, without further ado, let's get into unpacking the BIQU H2. So this is the latest version of this all-in-one package. So you got a instruction manual. And here is the hot end assembly. So it looks like it brings a little rubber duck. Got the heatsink fan. Some screws. Looks like some tools. A little fan grill. Heater cartridge. And a high temp thermistor. So this is important that it has this sleeve. That means that this thing will operate using higher temperatures. So that's pretty cool. We have the plug for the extruder. All right, so let's get into this. So I'd seen on another video that somebody was talking about how this grub screw was loose on his version, but this one is tight, so no problems there. And it looks like the original version, this gear was a black piece of steel, and this one looks like a higher quality material. Also, the bearing fits real nice. have the other gear and bearing. So again, it looks machined really well. And then there's 2 more bearings down there. So it looks like if you needed to change the orientation of this plug, all you need to do is just unscrew those 2 screws there, and that will free the stepper motor from this aluminum bracket, and then you can orient it whichever direction you need it to come out of. Pretty cool. Let's take a look at the extruder portion here. So now one of the problems that a lot of these direct drive Hotends have is that it seems that they have a gap. Let's see if you guys can see this. Turn on the light, might help. So usually there's a gap between this little channel and where the entryway is for the heat break. But it looks like they tightened up that gap pretty well, the way that they machined this part. You can see that. So I'm hoping that this thing will be able to handle flexible filaments really well. I mean, it looks pretty tight to me in there. I don't know if you guys can see that. Let me get a stronger flashlight. Yeah, there you go. You can see that real good in there. So you see that gear is completely up against that aluminum extrusion. Pretty cool. Yeah, so this is looking really promising. And another thing that I noticed is the ones that I saw reviewed online, they had a PTFE lined heat break, but it looks like this heat break is not PTFE lined because the neck is too narrow. So let's take a look at this heat break here. To remove the heat break, there's a couple of there's a little notched area here on the side of the aluminum housing, and there's a couple of grub screws in here. I'm just going to loosen the grub screw. Tight. Seems like that Allen key is kind of loose. That's not that one. That should be this Allen key. Oh wow, okay, cool. All right, so look, check this out, guys. So this is a bimetal heat break. Interesting. Yeah, I didn't think this came with a bimetal heat break, but it does. Let me yeah, check it out. All right, so one thing I noticed here right off the bat is that I'm not a fan of these tips with the broad heads. So what I think I'm gonna do, let me see if a different tip will fit in there. So it looks like, so the CoreXY tip is too short, doesn't have enough threads to it. So this would have been my first choice to try to use this, but that's not gonna work. And then I finally got some E3d nozzles, and these are the original ones from E3d. They're not knockoffs, and you can see, if you guys saw my previous video, it talked about that angle. So if you look here, you can see the difference in the angle on these these two nozzles here. You can see that the one has a it looks like it's about a 30-degree angle, and this one is a 45-degree angle. So this angle is the same, I believe, as the CoreXY. Yes, it is. See if I can get this thing to focus. Yeah, you can see that that angle is exactly the same. All right, and this so yeah, these are the same length. All right, so it looks like the E3d nozzle will fit on this heat break. So we're gonna, on this hot end. And yes, it does. Perfect. All right, so I'm gonna go ahead and install this right now. Okay, perfect. So I don't know if you guys already saw this, but I picked this up on Thingiverse. It's a torque wrench, and this thing works great. So I'm just gonna tighten this up right now. So I'm holding the block. Okay, so shout out to Doug O'Connor for sending me this AMD and Intel CPU thermal paste. This is a copper paste, very high quality, and will do a great job at improving thermal conductivity between the heatsink and the heat break. All you need to do is just put a little bit on your heat break. You don't want to get too crazy with these grub screws, just snug them down. All right, so now let's reassemble this thing. So to put the thing back together, we're going to start with this gear. And if you needed to make any adjustments to this, those two screws, I think I mentioned that already. All right, so you make sure that you put, to reassemble this, make sure that you put the bottom of the smaller gear into this bearing over here on the left side. So just line up those gears there, and it should just drop in. And then this one, the same thing. So you're going to line up this little pin here with the bearing and just drop it down. And that's it. Now on this part, if you see, you got the two spaces there for the bearings. So we're just going to drop it in there. So we're looking at this piece. So this should be a mirror of this. So it's going to go like this. You'll know when you get it right because it'll just drop right in. You may have to play around with it a little bit. All right, so the trick is to pull the lever, back towards you a little bit, and then it'll drop in. So right there, it dropped in, and then you can verify this by turning the gear and make sure it turns smoothly. And yeah, it does. Perfect. All right, so now we're just going to reinstall these screws, and these are long screws. And make sure that you don't lose the lock washer that's on the end of it. Again, this needs to be tightened, but not crazy tight. So as soon as the compression washer gets compressed, that's as far as you need to go. You don't need to go any further than that. All right, guys, so next step would be to take apart the stock Hotend assembly on this machine and then see what method we're going to use to try to mount this. All right, so I'm going to start by taking off the VGA cable. I like this this connection idea. The only thing I don't like is the weight of this cable. This cable is very heavy. So I think that maybe we can probably lighten that up quite a bit. Next thing I'm going to do is unplug the stepper motor. And then unmount it. It's got a couple of screws over here on the side. And then I'm going to release the Bowden tube. So I'm just going to squeeze this pneumatic fitting and pull it out of there. So let's take off this little cover here and see what we got under here. Pretty cool. All right, so what they're using is like a little breakaway board here. So I'm just going to unplug these, and they're labeled. So let's unplug these, and I'll show you guys how they're labeled. As you see here, it's got the X over here on the top, temperature probe. This one was the Hotend. I'm not sure what EO stands for, but then this one's the heatsink fan, and then the cooling fan. So two cooling. All right, so this is the fan assembly. And then it looks like it just uses a standard Creality Hotend. And I had already previously taken this apart, that's why it's missing the boot. But let's just set this over to the side for now. So it looks like, show you guys. So it looks like in here, they have a limit switch in there. So we're gonna remove that limit switch as well. And all right, so that's what triggers the limit switch is that bolt there. So let me take that limit switch off. So I'll make sure that I remember that it goes like this. And another thing that's kind of tricky with these machines is the tension on these belts. So you want to make sure that you mark how these belts are fastened. That way, when you're reassembling this, you can put it back to the tension that the manufacturer recommends. So I'm just going to take a Sharpie and just draw on the cable here. So what I'm going to use is a pen. I'm just going to draw on the belt with a pen. Let's see that. And all I'm marking is the end of the folded piece of timing belt where it meets with the belt. That way I know exactly where to put it. I'm going to do the same thing on this side. So let me zoom in here so you guys can see exactly what I'm marking. So all I'm doing is marking right here where the end of the belt is. Let me show you where the marks are. See that? So those are my marks right there. Okay, so one thing that I decided to make is are these little timing belt holders. So I had cut a piece of timing belt. Let me zoom in here so you guys can see. So I took a piece of the timing belt, I cut it off of one side, and I designed this part so that the timing belt will fit inside like that. So this will grip the timing belt, and then the elastic band, so this is just a rubber band. And I'll include these parts in the video description if you guys have a system like this that uses timing belts and you want a quick way to hold the belt so you can do maintenance to the hot end, you can use this. So this is just a rubber band around a pin, and I'll show you how it works. All I'm going to do is, this one's going to go upside down like this. I'm going to grab it back here, push it in there, make sure it's locked, and then I'm going to stretch this over to the other side and lock it down as well. So this is going to create tension here and allow me to cut free these wires. And then I'm going to do the same thing on the other side. So now these belts are free. You can see I have the tension with the rubber band. I'm going to do the same thing on this side. I'm going to grab my little rubber band tool here, push it on, I'm going to stretch it, and I'm going to come up and over the belt on this side and tension it up. So now my hot end bracket is free from the gantry. I can just unscrew it, and then to reorient this, it's going to go with the pins facing back. When we reassemble, just pay attention as you're taking things apart. so here's our bracket. So now let's sit down and try to figure out how we're going to mount this hot end. One thing that's important when you're dealing with hot end replacements like this is that you don't want to deviate too much from where the original hot end is, because most of these 3D printers, there's no way to adjust the offset other than using the limit switches. And in this case, this firmware is limited, at least with the current one that it has loaded on here. So I want to try to stay as close to the original position of the nozzle as possible. So what we want to try to do is take some measurements off this original hot end and find out what position it needs to be at. That way when we create our part, everything lines up as close as possible to what this measurement is going to be. So a good measurement to take would be to find the center point of this bracket here. So I'm just gonna get something to measure this with. This doesn't have to be super scientific, just relatively close, because you can use the limit switches to make some fine adjustments, but you know, you can't make you're not going to be able to adjust out 10 millimeters. So that's the reason we're doing this. So grab yourself some digital calipers. And the measurement that we're interested in is between the X and the center of this pneumatic fitting here. So I'm just going to grab here. And you know, you're gonna have to look down over this to get the measurement. So it's not going to be 100% accurate, but so long as you're relatively close. And a lot of times the manufacturers, when they design these parts, they'll use round numbers. So to me, and it may not appear so by this angle, but to me it looks like it's like they intended this to be 35 millimeters. So I'm going to lock it at 35 and then verify. Yeah, it looks to me like it's 35 millimeters. Okay, so if I look down here, you can see that it's lined up with the top opening of that pneumatic fitting, and we're right on the X right there, and our caliper is showing 35 millimeters. So this is what I'm going to use, and then you can apply the same thing to this. So when you position this, and unfortunately we're not going to be able to do anything with this bracket, the way to mount this is this way, but I don't have a whole lot of room left and right. And then on top of that, you're going to have the parts, the heatsink cooling fan on this side, so it can't stick out because the rail is in the way. So I'm going to have to mount mine either this way or this way, just depending on how much room I have. Let me take this off now that I know this measurement. Oh, and another measurement you also want to know is the measurement between the top of the bracket and the bottom of the and the nozzle. So let's take that measurement too before we take this apart. So we need to know this measurement. So we got 35 here, and then we need to know this as well. So I'm going to measure from the top of the bracket to the tip of the nozzle. So it's about, so it looks like it's about 80 and a half. 81. So I'm going to say it's 81. So 81 millimeters. Get that down somewhere. 35. And 81. Make a quick drawing here. So from here to here, it's 35. And from here down to the nozzle, it's 81. All right, so our tip needs to be right around here. So I don't think we're gonna be able to do it this way. Maybe this way. All right, I think it's gonna have to be this way, and the reason is because on this side, you have this handle sticking out here. So if I was to do it this way, and the distance between this and this is greater, I would have to have this way in here like this. And then it would also have to be low. So this handle would almost be rubbing up against this thing. And then we're also past the fastening points. The fastening points will be on the other side of the bracket. So I think it's gonna have to be this way. I think it would be better if it was the other way, but this way seems to be like we'd have more room for this. So let's jump on to OnShape and kick around some ideas and see if we can at least come up with a prototype. And then I'll refine it from there, and we'll print out the parts, install the Hotend assembly, and mount it on the printer. All right, a change I had to make is I had to turn the heat block. So I decided to mount it this way, like this. So if we have the original bracket, it would be mounted like this. But we're gonna have to put some of this inside of here, and I have to remove these standouts. We're not gonna do anything with this bracket because I think I can design one in OnShape. But that's my thinking here. Another reason why it's this way, and it has to be with the heat cartridge facing the front, is because the heat block is shorter on this side. So we want as much space between here and the bracket as possible. That way we're not melting anything. But I think that would be the best way to mount this. Also, mounting it this way will give us the option to use dual cooling fans. I'm not sure if this gear is going to be in the way, but we'll figure it out as we go. On this step, we're going to start putting the hot end together. I'm going to mount the fan to it. That way we can get an idea of how much extra space the fan is going to occupy on our bracket. And the fan screws are these, it comes with 4 screws that are the same length here on this kit. 2 of them are for the fan. And the fan gets oriented this way. So you're going to use these 2 places here for the fan screws. And the fan goes with the label facing down. And again, you don't need crazy tight, just snug. Now we finished up our first print. So this is going to be the bracket that's going to hold it to the carriage. And the idea is to mount the fan like this, or to mount the hot end like this. Something like this. And it looks like we're going to have to create some kind of a support for this. Okay, so these are the 2 little reinforcement pieces that I made for the bracket. The way this is going to work is it's going to fit in here like this. And it's going to be 1 on each side, and we can screw them down. So what I have here is a tap. And let me see if I can tell you guys what size this is. .3mm by .06 thread pitch that are used throughout this hot end bracket. So that's what we're going to use here. And all I'm doing is that I'm chucking it here on my hand drill. Yeah, make sure it's tight. And I'm just going to tap these real quick. All right, so I'm going to tap the rest of these and then we'll put it together. So I also tapped these places here. So this is going to be where the bracket that bolts onto the extruder is going to go. So these 2 get tapped. This one gets tapped. This one is a straight through, and it's going to go into these parts right here. On the back side, we have the cover for the little breakout board here that the VGA cable plugs to. So these get tapped. This one gets tapped. This bottom one gets tapped. These 2 are countersunk, and they go into this little support piece. These 2 middle ones get tapped. These are the ones for the limit switch, the X limit switch, and then these also get tapped. These are the ones that hold on to the breakaway board. So those are already done. Now we can start putting this together on the linear rail. Okay, so our bracket's going to go with the opening where the hot end is going to mount facing the back of the machine. I'm just going to slip this over here and bolt it down. now since we had our belt keepers, we can go ahead and put our belts back on. Now what I did, instead of using the wire ties, I created these little belt keepers, and they'll grab the two sides of the timing belt teeth and mush them together. That way we don't need the wire ties. And to install them, all you got to do is just slip it over the belt. Let me get in close here so you guys can see. So what we're going to do is slip it over the belt and then down, and then push the timing belt into the groove, just like that. So this is not going to come off because the timing belt teeth are mashed together, and this little plastic piece will keep them gripping each other. Same thing on this side. And all I'm doing is I'm lining up the marks that I already made. All right, now we should be able to remove our belt keepers, and our tension should be set. All right, so there we go. All right, so I'm going to install the little breakaway board. So this is a little VGA board. Next thing we're installing is the X limit switch. It looks like I'm gonna have to add a spacer here because it's not triggering the limit switch. So I'm gonna 3D print a part real quick, and then we'll try it again. So I made this little spacer on OnShape, and that's gonna allow me to trigger the switch. Not sure why that happened. Maybe because the material is thicker and it brought the switch down some. Anyway, we're gonna try this and see if we can trigger the switch with this. So let me show you what I did here. Right there, it's triggered. I think I'm going to extend it a little bit more. So I'm going to modify this and print it again, because what's happening is this this little piece of plastic is hitting the wheel, even though it's triggering it. It's just barely triggering it. So I want a little bit more safety margin there. what I wound up doing is I switched out the little keeper for a couple of wire ties, just like it was from the factory, and this now allows it to get closer to the wheel and engage the limit switch. So let me show you. So right now it's engaging the limit switch. There it goes right there. All right, so that's good. Next up is going to be the support bars. So I'm going to put those in there next. This side gets the support bracket for the, we got to put the bracket in on the other side. Now we can install a little breakout board. In this step, we're going to install the 3D printed parts that we made in OnShape. And we're going to reuse these parts cooling fans from the stock Hotend. So we're going to take that off. All right, so we're going to reuse these parts cooling fans. And let's start installing this on the One thing I ran into is not enough clearance for the insulating tubes. So what I decided to do is just cut off those heater cartridge ends, solder them onto the leads directly without the metal crimp, and use some heat shrink to reduce bulk. I don't think this is going to cause a problem, but I'll let you guys know further on down the video if it does. But for now, this is what I'm going to do. Just fish your wire for the cooling fan underneath the space provided by the bracket and start screwing it down. Same thing here on the other side. Just fish your wire through first before fastening the bracket down to the BIQU Hotend. What I had to do here is I had to create a really small little plastic washer to stand off these screws, because when I put them in the first time, they were hitting the heat sink on the direct drive unit. And lastly, you can go ahead and install your ducts. Now we got a real compact unit that we can install onto the bracket. I'm just putting on some JST connectors on the end of this thermistor wire. And this heater cartridge and thermistor that this BIQU direct drive came with is a high temperature kit. So they're claiming 500 degrees Celsius, which I think is super hot. But the heater cartridge is a 70-watt heater cartridge. And this thermistor is sleeved with a metal cover to protect it from melting. So it should exceed the stock temperature by a wide margin. And you can use a set of tweezers here to push down these pins and release them. That way you can reuse the JST sleeve. To install these things, you got to make sure that the fans aren't mounted because you're not going to be able to access the screws needed to fasten it to the gantry bracket. All I'm doing here is just fishing the cables through the opening all the way through the back side where the little breakout board is. And I found it easiest to get the couple of the screws on the side bracket. You could just put one on the top on each side, and that'll stabilize it a little. That way you can work with it. And then once you have those in place, go ahead and put the other ones on. And then lastly will be the screws that go through the side bracket into the support pieces that fasten the two sides of the gantry bracket. And once the screws are on and tightened, then pull the slack out on the side cooling fans and start installing them. What I decided to do is, originally I was gonna have the second fan on here so I could get cooling from both sides. And then I found it necessary to be able to get to this gear here so you could load and unload filament if you have any trouble doing it. It's important to be able to get access at this. But I really like the fact that I can have the dual cooling. So what I'm going to do is I decided to remove all of this material in here. So this will give, and then there's going to be a slight gap between the edge of this fan and this opening here. So the fan in the front is drawing air through these fins. And the fins on the right side, there is no fins, it's just solid. But all the openings are here, along this side and along the bottom. So the bottom is open. This side is partially restricted because of this cables, and then it's going to have the fan covering it. But I think there's enough gaps around it that it can draw air up through all these gaps to cool those fins here on the side. So I'm going to go ahead and leave it like this. I'm going to mount my fan back on, and in the event that I do need to get to this gear, all I would have to do is take these 4 screws out and then I can get access to it. But I think I'm going to be doing more printing than changing filament. So that's why I feel that it's important to have this second cooling fan. All right, and then because of the design of this machine, there isn't any room. I've seen a lot of designs where they have this side cooling fan tilted out. Unfortunately, with the way this machine is designed, there just isn't enough room along the edges to do this. So this is the only solution that's going to work for me. So let me mount that thing up, and then we'll do some airflow testing. I got the fan running here at 100%. This video's gone on long enough, so I'm going to go ahead and wrap it up here. I'll have to do a follow-up video on printing with the BIQU H2, along with setting the E-steps, reversing the direction of the extruder, and all the other little upgrades I had to make to this Corception 300 to get it to print reliably. Till next time, guys, God bless.